Hello children, hope you have seen the last worksheet what we have uploaded, and you have solved those, like writing the formulae. Hope you have done it. The next thing what I am going to teach you is about the chemical reactions. So we have to just see, I will show you one activity, like suppose I am taking a paper. Okay, and I am just burning this paper. What you can see after some time, this paper will burn, and what you will get is some ash. You can see that ash is formed here. So here a new substance has been formed. Previously it was a paper. After burning it becomes an ash. A new substance is formed. You can see a new substance is formed, isn't it? So here, when a new substance is formed, we say that a chemical reaction has been occurred, has been taken place. But if I take a piece of paper, and now I am going to tear this, is it that a new substance is formed? No, just we can say a change in the shape or size, it has been changed. So this type of thing, like there is only a change in the shape or the size, or sometimes you can say even this one, if you can take, these are ice cubes. If I keep it for some time, you can see it will change into water. That means state has been changed. Solid state has been changed into liquid state. So there is no new substance is formed. No new substance is formed. Only the state has been changed, or the color is changed, or shape or size. Such changes we say it as physical change. But the change where a new substance is formed, completely a new substance is formed, then it is called chemical change. So hope you understood the difference between physical change and chemical change. Now when we say that paper is reacting with air or oxygen precisely, and we get ash. Yes. Now here, paper and air are the substances we used first, and last what we got it is ash. The substances which take part in reaction, we say them as reactants. What are reactants? The substances which take part in the reaction are called as reactants, and the substances what we produce after the reaction, we say them as products. So in a chemical reaction, in a chemical change, always reactants convert to become products. Okay, if you want to write in a chemically some other reaction, like magnesium plus oxygen gives magnesium oxide. Balancing. Okay, here which are the reactants? Magnesium and oxygen are the reactants, and magnesium oxide is the product. If I take one more, like calcium carbonate, when we heat it, we get calcium oxide and carbon dioxide. Which is the reactant here? Calcium carbonate is the reactant, and we have two products, calcium oxide and carbon dioxide. So hope you understood what you mean by reactants, what you mean by products. In any chemical change only we have reactants and products. Now when a reactant is getting converted to product, or when a chemical reaction is taking place, some laws has to be followed. That laws are called as laws of chemical combination. What it is? Laws of chemical combination. And we have to learn two laws. The first law is law of conservation of mass. Law of conservation of mass. I am going to explain about this law, that is law of conservation of mass. Now, what do you mean by law of conservation of mass? Now, in any chemical reaction, For example, we'll take the simple reaction like carbon plus oxygen gives carbon dioxide. Okay. Now, if I calculate the mass of the reactants and mass of the product separately, we'll see that. I have noted down the mass of different elements, like hydrogen mass is always 1, oxygen is 16 units, carbon is 12, calcium 40. So, a few elements, important elements, we have to know the masses. Now, if I calculate the mass, carbon, how many atoms? Only one atom, and carbon's one atom mass is 12. So 12 plus oxygen, one atom's mass is 16. 16 into 2 is 32. How much 12 plus 32? It is 44 units. So this is the 44 units is the mass of the reactants. Now we will calculate the mass of the products. Carbon is 12 plus oxygen, how many? 2 oxygen. So 2 into 16. 2 into 16. So 12 plus 32. Again we are getting 44 U. So what you understood? Mass of the reactants is equal to mass of the product. And that is what law of conservation of mass has been telling about. So what is law of conservation of mass? Mass of the reactants is equal to mass of the products in any chemical reaction. One more example we'll see, and we'll try to prove it. The mass of law of conservation of mass is correct. If you take calcium carbonate, I told you when you heat it, it changes into calcium oxide and carbon dioxide. Now we have to calculate the mass of the reactant separately and mass of the products and see whether it is same. Now calcium mass is 40. How many atoms? One atom. So 40 plus carbon also 1. So 1 into 12. 12 plus oxygen 3 atoms. Each atom's mass is 16. So 16 into 3. Okay. So 40 plus 12 plus 48. How much? 100. So reactants mass is 100. Now we will calculate separately products mass. Calcium oxide. Calcium mass is 40. So 40 plus oxygen here is 16. So this is the mass of calcium oxide. Plus carbon dioxide. Carbon is 12 plus oxygen 2 into 16. 2 into 16 is 32. Now how much it is? 40 plus 16 is 56 plus 44. 56 plus 44 is 100 U. So what you understood here again? The reactant's mass is equal to product mass. So that proves law of conservation of mass. So what is law of conservation of mass? Simplest way to define is, in a chemical reaction, the mass of the reactant is always equal to mass of the product. But we have to define how Lavoisier defined it. He is a person who have introduced this law. What he said is, in any chemical reaction, mass is neither created nor destroyed. Mass is neither created nor destroyed. Means mass cannot be created, mass cannot be destroyed. That means the total mass of the reactant is equal to total mass of the product. So how to define law of conservation of mass? Two ways. One is, in a chemical reaction, the total mass of the reactants is equal to total mass of the products. Another way is, in a chemical reaction, mass is neither created nor destroyed. And you can prove it with any example. Any chemical reaction you can take and show that total mass of the reactants is equal to total mass of the products. Fine. The next law is law of constant proportion or law of definite proportion. And it has been introduced by the scientist Joseph Proust. Then what it is? If you take water, you know H2O is the formula of water. Yes. Now what is the source of water? We can get water from rain, from well, from bore well. Many sources are there. And in any source, the formula of water remains the same, H2O. Is suppose if you write H2O2, it is not water, it is some other substance, hydrogen peroxide it is. So it is, say, always the formula is same, elements are same. And what about the mass? Suppose I take the mass. I told you hydrogen is 1, oxygen is 16. Now if you take, what is the ratio of mass of hydrogen and oxygen in water? What is its ratio? Okay, suppose hydrogen 2, 2 into 1, 2 is 2. Hydrogen's mass is 2 in water, and oxygen mass, only 1 oxygen, and oxygen mass is 16. So 2 is to 16, that is 1 is to 8 if you cancel with 2. So in water, the ratio of hydrogen and oxygen, the mass ratio is always 1 is to 8, always, and that is law of constant proportion. In any chemical substance, it is a chemical substance, okay, the elements present are always in definite proportion by mass. We are talking about mass. If you are taking the mass, it will be always constant. The elements will be constant and the ratio also will be constant. If you can take some other example like ammonia, NH3. Nitrogen's mass is 14. So what is the ratio here? Nitrogen is 14 is to hydrogen 3 into 1, and this will be always 14 is to 3. We cannot cancel it or we cannot simplify this. 14 is to 3 will be the answer. So in ammonia, the ratio of the mass of nitrogen and hydrogen will be always 14 is to 3. That is law of constant proportion. Using this, you will get some questions like, suppose in water, what is the ratio we said? In water, the ratio is always 1 is to 8. That means, if you take 9 grams of water, how much hydrogen and how much oxygen will be present? It will be having 1 gram of hydrogen and 8 grams of oxygen. Oxygen will be 8 grams and hydrogen will be 1 gram. Both together we are getting 9 grams. And here it is law of conservation of mass again. Yes, 1 gram plus 8 grams should be 9 grams. If I say, if I am using 3 grams of hydrogen, how much water will be produced and how much oxygen is required? Suppose 1 gram requires 8 grams. 3 grams required how much? 24 grams, isn't it? 1 into 8 is 8. So 3 into 8 will be 24. And how much water will be produced? 27 grams of water will be produced. So this is how some problems will be asked for you, like suppose they say that 27 grams of water contains how much hydrogen, how much oxygen. So first we should know in water what is the ratio of mass between hydrogen and oxygen. Accordingly you have to calculate. Now there is one question will be asked like, suppose I am giving 3 grams of hydrogen and 30 grams of oxygen I am using. 3 grams of hydrogen and 30 grams of oxygen. How much hydrogen or water will be produced? How much it will be produced? Always the ratio is 1 is to 8. That means 3 grams of hydrogen requires only 24 grams of oxygen. It doesn't want 30 grams, only 24 grams. Yeah? Okay, but we are providing 30 grams. So what will happen is, remaining 24 grams will react with 3 grams and produce 27 grams of water, and remaining 6 grams of oxygen will be unreactive. It won't be taking part in the reaction. So always the ratio will be fixed, 1 is to 8 only it will be always. Whether you give more or less, it can react according to this ratio. That is law of constant proportion. So now we will discuss few problems to be solved based on these two laws. I'll read out one question which is given in your textbook. In text question it is. I'll read out. In a reaction, 5.3 grams of sodium carbonate reacted with 6 grams of acetic acid. The products were 2.2 gram of carbon dioxide, 0.9 grams of water, 8.2 gram of sodium acetate. Show that these observations are in agreement with the law of conservation of mass. And they gave the equation. Now, I'll discuss this. Now here sodium carbonate plus acetic acid is giving sodium acetate, carbon dioxide and water. The first thing is you should know which are the reactants, which are the products. Reactants are sodium carbonate and acetic acid, and products are sodium acetate, carbon dioxide and water. Now which law they are saying that whether this law of conservation of mass is followed in this reaction or not. So we have to calculate the total mass of reactants, and then we have to calculate separately total mass of products and see whether both are equal or not. Now reactants mass 5.3 plus 6 grams. How much it is? 5.3 plus 6 is 11.3. Now products mass 8.2 plus 2.2 plus 0.9. If we add this also you will get it as 11.3. So that shows the total mass of the reactants is equal to total mass of the product, and which law is followed here? Law of conservation of mass. Fine children? So this is one problem which has been asked. You can solve that. Next, one more problem, back of the textbook. Last exercise question. We'll find one more question, that this one. What you can say is, just I'll read the question. When 3 grams of carbon is burnt in 8 grams of oxygen, 11 grams of carbon dioxide is produced. When carbon and oxygen is reacting to form carbon dioxide, 3 grams of carbon is burnt in 8 grams of oxygen, 11 grams of carbon dioxide is produced. Is it clear? Now the question states, what mass of carbon dioxide will be produced when 3 grams of carbon is reacting with 50 grams of oxygen? So this is the question, this type of question is what I discussed before, that is law of conservation of mass. Once again I will write it. Carbon plus oxygen gives carbon dioxide. Carbon is 3 grams given, oxygen is 8 grams. So when these two react, we get 11 grams of carbon dioxide. And the question is, if we are using 3 grams of carbon and we are using 50 grams of oxygen, how much carbon dioxide is produced? Now which law is following here? We have to use law of definite proportion. That is, if 3 grams of carbon is using 8 grams, it will be always constant. That means 3 grams will only use 8 grams. Remaining 42 grams will be left behind, which is not reacting, which is not taking part in reaction, and we get always 11 gram of carbon dioxide. And which law is followed here? Law of definite proportion or constant proportion. It is being proposed by John Proust. So what is law of definite proportion states? In a chemical substance, the elements are always found in fixed proportion by mass. So learn these two laws, and we'll be uploading a worksheet based on few problems and statements on this laws, and you have to solve that. Try to understand it, read the question textbook, and there are certain experiments which are proving this, both the laws, and try to solve this. Fine children, do that.